Hello, and welcome to 5 Minute Math. Today we are looking at the third grade STAAR test that the students took in 2025. My name is Aaron Daffer. You can follow along by using the custom statewide item analysis report you see using the tiny URL or the QR code on your screen. If you would like to jump ahead to any of the specific items, you can do so by using the timestamps you see on the screen. Also, if you scroll along the bottom, you'll see the bookmarks for each individual item. So for number one, we are looking at 3.2a. This is composing and decomposing numbers. We are being asked to find two expressions. So this is a 2-point problem that are equivalent to 15,090. And so we need to look at the place value chart, right? So we can go ahead and just make our place value chart if we want to. We can put our numbers in there. And really, if we want to throw values underneath, we can say that's the ones, that's the tens. There's no ones, there's no hundreds, so that's going to be kind of our tricks that they're going to try to trip us up with. And so if we wanted to do this in just expanded form, right, we would do 10,000 plus 5,000. We'd skip the hundreds, we'd add the 90, and we'd skip the ones. And so we see that down here at the bottom, but we also need a second answer. And so what we would need students to see is that you can combine these two, and you can say these are 15,000s. You can take both of those numbers, those digits, and put those in the thousands place, 15,000s or 15,000. That's going to work right there. And so those are the two correct answers, the second and the fifth answer. Now, if we look at how we scored on this, so we had 73% of our students get both of these items correct. We had 22% get just one correct. We don't know which one is correct. And amazingly, only 4% got zero correct. Now, if you take half of the 1 point and add it to the 2 point, we can look at an effective percent correct as 84% correct. So, as you can imagine, this was a softball that they tossed us at the very beginning. This was 84% correct. So that equals our second easiest item on the entire test. And typically that's how these tests are designed, that they start easy, they kind of crescendo in the middle, and then they end on the easier side as well. And so we would just want to be wary of this 1,000 right here, because that's a 1 in the thousands place, not 1 in the 10,000s. And then we've got a 9 in the hundreds place rather than a 9 in the tens place. And that's kind of the pattern down here. We've got the 1 and the 5 and the 9. They're just in the wrong locations. For number two, we are looking at 3.4J. It is relationship between multiplication and division, right? So we've got 45 toy cars in 5 different colors. And so this is our total. So we want to make sure that we recognize that. They're the same number of cars in each color, so this is letting us know equal groups. When we are dealing with equal groups, most likely we are going to multiply or divide. Now, if I've already got my total, that means we're not going to multiply. So we can look at it like this. I've got 45 in 5 different colors. So I can just kind of break it up like this. The same number of cars in each color, and I'm trying to figure out how much would be in each color. Well, I would need to know that 9, 18, 27, 36, 45, because 9 times 5 makes 45. And so my answer here is going to be this A. And we see here that we actually had 68% of our students get this one correct. And then we had 17, 8, and 7. So the the distractor here is going to be that they saw the 5, they saw the 45, and they saw the equal groups. And they knew that if you are going to use equal groups, you're going to multiply or divide. Well, they chose multiply, and so they ended up with this new total of 225, which doesn't make sense. But at least the students that chose B were recognizing that we had equal groups. So this was fairly easy, still on the easy side, sixth easiest item on the test. We're just trying to recognize this and turn it into a multiplication or division problem. For number 3, we are looking at 3.3b. 3.3b is dealing with proper fractions on a number line. And so we need to figure out what fraction this point represents. And so what we want to do is we want to come up with a numerator and our denominator. So our numerator is going to be the number of tick marks. And then the denominator is going to be the number of spaces when we're dealing with a number line. So let's deal with tick marks. If we start at 0, I've got 1, 2, 3, 4, 5. And then spaces. 1, 2, 3, 4, 5, 6. There are 6 spaces. 5/6 is almost one whole. That makes sense that it's close to the end because 5 is almost 6. And so we've got our 5/6, and that's really all we're doing on this one. 71% of our students were able to get this. And we do see that A was our biggest distractor, and they counted this 5, and they counted this as these are the tick marks. And so students that missed this kind of flipped these, and they knew that it was 1 away from the end, so they counted the tick marks 1, 2, 3, 4, 5. So when we're working with students here, we want to make sure we clearly specify when we're representing fractions on a number line. The numerator is the tick marks, the denominator is our spaces. And so our answer here is going to be D. And for number 4, we are looking at 3.5e, and that is the real world number pairs standard. And so Lila is reading 4 books every month. The table shows the number of books Lila reads. All right, so we need to find a number sentence. Well, let's find our rule. Then we can find our number sentence. And you see we've got some drop downs here. This is a 2-point problem, plus, minus, times, divided by, and then we've got numbers there. So if we could just get our rule in words, in numbers, we can turn those into words. And so when we're going from 2 to 10, right, we're getting bigger. From 4 to 20, we're getting bigger. From 6 to 30, we're getting bigger. So we could do this. We can do 2 times something equals 10, or 2 plus something equals 10. Those are the 2 ways that we're going to get from 2 to 10. So 2 times 5, 2 plus 8. All right, so whatever rule we have needs to work for the rest of them. So let's try 4 times 5, or 4 plus 8. All right, we want to bring these down. That's going to equal 20. That's going to equal 12. So that's not what we need. So it looks like we've got a times 5. Let's verify this last one. 6 times 5 equals 30. Yes. All right, so we are going to times 5, right? And so let's get that at least. Times 5. That's our correct answer. Now, how did we do? This is our 2-point problem. So both points, both correct answers get you 2 points. That's 51% of our students got that correct. 1 point was 26. Now, we don't know which one of these was correct and which one of these was incorrect, because obviously if you only choose one, the other part obviously doesn't make a true statement. But we had 23% of our student get 0 points. So this was a little bit more difficult when you look at getting full credit. But remember, you can get half credit. You can get that 1 point. So if we take half of that 26, right, you're going to get 64%. So anything above 60%, we're still kind of happy with. So this ends up being our 8th easiest. But if you're looking at just who gets full credit, the 2 points, only barely half of our students got that. So this was a little bit tricky. When we're working with students on this one, we need to remember how are we evaluating these tables, right? And if the words go left to right, if the columns are left to right, we need to work left to right. Increasing, decreasing, that means we either add or multiply, or if we're decreasing, we're going to divide or we're going to subtract. For number 5, we are looking at 3.8a. We are summarizing data here. And so we've got a dot plot, and we are measuring the heights of some pea plants. And we need to just find a list that this represents. So each of these dots represents 1, right? So I've got a 2, I've got a 3, and this is what I would suggest when solving this. Let's just list them out because you see we're just trying to find a list. We're not even finding a tally chart here. So I've got 1, 2, 3, 4s, which means I need 1, 2, 3 4s, 2 5s. Each dot represents 1, and then a 6 and a 7. All right, so we see, let's just go through all of them. So A, we've got a, a 2, a 3, a 4, 4, 4, 5, 5. Oh, look at this. I've got 2 6s, and I only need 1 6. So that's tricky. B is 2, 3, 4, 4, 4, 5, 5, 6, 7. So this looks good. This one's missing a 4. It's 4, 4. And this one just lists each one once. Okay, so our answer is going to be B. Now let's look and see how our students did on this. It was actually fairly easy. 77% of our students got this correct. Not that difficult. Now, there is a distractor. Look at this. 16% of our students chose D. Let's look at why. Well, 2, 3, 4, 5, 7, 5, 6, 7. 2, 3, 4, 5, 6, 7. They just represented each number once, which means we've got 16% of our students that probably didn't interact with the dot plot, didn't really know how to read it. Because if you know how to read a dot plot, if you've worked with it, this is just an exposure issue. You know that each dot above the number represents a data point. But if I have no idea what to do with this, it does make sense for me to just grab these numbers at the bottom and just think those are the answers right there. So this is an exposure issue. We have to make sure that our students have plenty of at-bats with this. For number 6, we are looking at 3.4a. We are solving addition and subtraction problems. And we've got some times that we've spent hiking in the summer and the fall and the winter. It makes sense that we're not going to spend too much time in the summer, too hot, too much time in the winter, too cold. Fall is just perfect. Now, how many more hours? All right, so this is going to be a comparison. Does Tina hike during the summer and winter combined? Okay, so I'm going to do summer and winter combined, then in the fall. So I'm going to draw my strip diagram with 2 different bars here because I'm going to combine my summer and winter. I'm going to compare it to fall, and I'm looking for the difference. That's what I'm looking for. How much more? So my summer is 360. My winter is 344. And then my fall is 610. All right, so this is definitely a 2-step problem, which is probably going to make this difficult for some students here. First, I need to combine my summer and winter, so 360 plus 344. That's going to be 704. So step 1 is to add those two 704. And look, I've got an answer right there, 704. But that's not it, because that's just simply the combination of the summer and winter. I need to figure out how much more that is than the fall. Now I need to subtract the fall. I'm going to need to regroup. And that's going to be 94. So there's a 94 hike gap between the combination of summer and winter and then fall. So my answer here is going to be C. Let's see how we did on this. Only 52% of our students got this correct. 30%, which should not surprise us, got A, because this is simply step 1 only. We had 7% get B and 11% get D, but 52% of our students only getting this means we need a little bit of spend some more time on our 2-step problems. And you notice what I did first. Before I took this, I took all of my words and I drew a strip diagram. If you can draw a strip diagram, then you can find the operation, or in this case, the operations needed to solve it. If we can help our students create more strip diagrams, that will help them select the correct operation or operations. So this was still on the easier side. This is tied for our 12th easiest, which means we've got some hard ones coming up if 52% gets us on that easier side. But there's only 30 questions, which means that's about in the middle of the test. For number 7, we are looking at quadrilaterals. This is 3.6b, and this is a hot spot. So we need to select two different quadrilaterals, and it's pure vocabulary. If you know what a quadrilateral is, this is the world's easiest problem. And in fact, this is the first easiest item on the entire test. I'll go ahead and give you that spoiler alert. First easiest item on the test. What is a quadrilateral? Well, quad should make us think of four. We use quad in quite a few words. We can even think of that quarter. It's not quad, but it's got the QUA, right? There's 4 quarters equal $1. So simply, it's a four-sided shape. That's what we need our students to memorize. A triangle is a three-sided shape. A pentagon is a five-sided shape. A quadrilateral is a four-sided shape. So I've got my parallelogram here. I've got my square here. That's got 5. That's got 3. That's got 3. So if for some reason I didn't know what quadrilateral was, if I put the number of sides there, I would be stuck between two triangles and these two quadrilaterals. If I know a triangle is called a triangle, then I would be left with the two other four-sided shapes. So even by process of elimination, it is possible to get the correct answer here as long as we use a little bit of reasoning. So how did we do? Well, I told you this was the easiest problem. So we had 79%, almost 80% of our students get 2 points. That's fantastic. 13% got 1 point. Now 8% got 0 points. That's a little bit scary, but if you put these two together, you're looking at 86% correct, which makes it our easiest problem on the test. But the easy ones are going to be disappearing soon. In fact, let's get to our next one. Number 8, we are dealing with 3.5b. We are representing multiplication and division problems. And when we represent them, it's either going to be an equation, might be a strip diagram, might be a number line. In this case, it looks like we're dealing with equations. There are 12 students in a class. All right, so this is my total. Let me draw a strip diagram first. I've got 12 students in a class. So I'm just going to draw this right here. That's my total. Half of the students play an instrument. All right, so I'm just going to draw this. I'm going to be cutting this up into chunks. So I'm going to do half play an instrument. I can kind of do that in my head. What is half of that 12? That's going to be 6. So 6 kids, that's half of 12 that plays an instrument. And there are an equal number of students who play the guitar, piano, and violin. All right, so of those 6, let me change colors here. These instruments, right? We had to know that an instrument is the same thing as that guitar, that piano, and that violin. So there's an equal number. So I'm going to do this right here. And I'm going to, instead of using that 6, I'm going to put that 6 right here. That's this part, right? That's half. And then I'm going to say there's an equal number of, take that 6, put it into 3 equal groups. Now I can put, all right, so that would be 2, 2, and 2. If I needed to figure this out. But how can I turn this into an equation? Well, what did I start with? I started with my total, and I took half. What does half mean? Well, there's two ways to do it. When we get older in middle school, we'll multiply it by half. But we're not quite there yet. So in 3rd grade, we can also divide by 2. That equals half. Half means you multiply by 1/2 or you divide by 2. All right, that got me my 6. Then of that 6, what did I do? Well, there are equal groups. And I know there are 3 equal groups because there are 3 equal instruments. And so then I took my 6 and I divided it by 3 equal groups and I got my question mark, but I know that 6 divided by 3 makes 2. So we do see our answer down here at the bottom. Our answer is going to be D, but as you can imagine, this was difficult. Only 38% of our students got this correct. If we look at our answer distribution here, for the most part, we've got a lot of guessing. Look at these 17, 23, 22. This is a lot of guessing. At least that's my guess. Simply because when you get near 25 on some of these answer choices, that means that people aren't making real choices. They're just randomly guessing. I'll put a question mark on there. One of the things that made this so difficult is on a two-step problem, we're used to doing two different operations, but look what I did on this two-step problem. You actually divide it twice. And that might not be a two-step problem that our students are familiar with. They know how to add twice, they know how to add then subtract, they know how to multiply twice, they know how to multiply then add, but then dividing twice is not very common. So we need to make sure that we're giving our students exposure to all of these different types. And this was actually tied for our sixth hardest item on the test, 38%, which means that's only our sixth hardest. We've got some more difficult ones coming up. For number 9, we are looking at comparing and ordering numbers. So this is 3.2D, and we are taking a look at these stadiums here, and we need to find the stadium with the least and the stadium with the greatest. And our answer selections are simply going to be the four options, W, X, Y, or Z. And it's not going to be that difficult. They all go to the same place value. So let's go ahead and just make our place value chart here. Let's just put our numbers in there. So this is going to be my 10,000s, my thousands, my hundreds, my tens, my ones. So 7, 4, 8, 6, 7, 7, 1, 6, 0, 8. I want to make sure that we are writing this down, even though this is a digital test. This is one we want to write down because we can easily line them up like this, and we can make sure we're doing everything. We're looking for the least. Okay, so when we're looking for the least, always start with the largest place value first. They're all sevens. So we're really not even going to pay much attention to the 10,000s place. It doesn't do us anything. We are going to look at this thousands place. So we keep moving to the right. If we're looking for the least, look, I've got a 4, 1, 6, 4. That's the only one I need. So this is going to be Stadium X, right? And so Stadium X is going to have the least because it's got one in the thousands place. The others have fours and sixes. That's pretty simple. Now let's look for the greatest. I'm not looking at the 10,000s. It doesn't do me any good because everything is a 7. And I've got the 6. And that's bigger than a 4 or a 1. And that's Stadium Y. Super simple. And if you think this is super simple, then you are correct. We actually had 72% of our students get 2 points, which is really good. 1 point is 14%. And then we still had 0 points, and that's 14%. So if you take your half of your 14 and your 72, you're going to end up with 79% correct if we wanted to look at it as just a single metric. And that is pretty good. That's good enough for the third easiest item on the test. There really wasn't much trick because you only had to go to that thousands place, right? The two fours that would have made you go to at least the hundreds place, they were not the least or the greatest. So nothing really happening on that one. So for number 10, we are looking at multiplication and division word problems. And that is going to be 3.4K. And so we've got Amy, Carl, and Liz equally sharing 60 blocks. All right, so once again, 60 blocks. They give it to us, and that looks like the total. All right, so I'm going to take this, just draw that very first sentence. So Amy, Carl, and Liz, there's 3 of them. I'm going to do this right here. All right, so I'm going to do Amy, I'm going to do Carl, and I'm going to do Liz. I'm not going to write in there in case I need to do something with it, but I could do 60 divided by 3, right? That's going to be 20, 20, 20, 20, 40, 60. Now, Amy. So now, step 2, we're just looking at Amy. Shares her, or divides her share into 4 equal piles. So I'm going to do this. All right, so this 20 right here is just Amy. How many building blocks are in each of Amy's pile? Well, we're going to take this 20. We're going to split it into 4 equal groups. So that's going to be 5, 10, 15, 20. So my answer here is going to be C, 5. Now, take a look at this. Only 21% of our students got this correct. Talk about a distractor. We had 55% of our students choose 15. Now, how in the world are we getting 55% of our students choosing 15? Well, it's kind of like a step 1, but we take this 60 and then we divide by 4. So 60 divided by 4 equals 15. It looked like a one-step problem. What they missed was that this was only Amy's blocks, not everyone's blocks. So they took the 60 and the 4 and divided to get 15, but they didn't necessarily capture the fact that Amy doesn't have 60 blocks. Amy only has a portion of the blocks. Now, if you got B, you actually got kind of close, right? This is your 60 divided by 4. What we did to get B is you took your 60 and you divided it by 3, because you realize that Amy, Carl, and Liz are equally sharing that. That got you 20. But then instead of dividing the 20 by 4, even though it literally says divides, you subtracted. And that's how we got B. So this was an extremely tricky problem. This was the second hardest item on the test. Two-step problem. You notice what I did first. Always draw a strip diagram on these word problems first. If you can spend your energy trying to accurately represent the relationship of the strip diagram, that will help you figure out the answer, or sometimes you need to use it to help you figure out the equation to find the answer. For number 11, we are looking at perimeter. It's a 3.7b. And we have a rectangular birthday card. And so let's just draw a rectangle here. We got a length of 9. We've got a width of 6. And we're simply looking at the perimeter. Well, if we look, we're not necessarily going to find the perimeter equation yet. The formula for perimeter comes out in 4th grade, and then it's going to be on there for quite a while. So we don't necessarily have a perimeter formula to deal with in 3rd grade, but we're still dealing with how to find perimeter. Remember, perimeter is all the way around. So if the top side is 9, bottom side is 9. If the left side is 6, the right side is 6. So really, we're just going to take these numbers, right? We're going to take 9 and 9 and 6 and 6 and add them up. So those two make 12, those two make 18. 18 and 12 is going to make 30. So 30 inches is going to be our perimeter, and only 47% of our students, not even half, were able to get this. And look, we had 24% choose A, 24% choose B. Not many students choose C. Let's look at A and D. So for A, these students weren't quite sure what to do. They took the two numbers and they added them. 9 plus 6 equals 15. Also, if they weren't sure what to do, you can multiply the two numbers. 9 times 6 is going to equal 54. So this is a vocabulary issue. What does perimeter mean? Notice how I immediately drew a picture to make sure I picked up all the sides, all 4 sides, because they only give you 2 sides. And so unless you have that picture, you might forget that you need to double the length and then double the width. So we need to make sure that our students are finding perimeter not simply from pictures, but from problem situations in which they need to draw their own picture to represent what's going on. For number 12, we are looking at 3.8a. Again, we are summarizing data. And so we have Vienna, and we've got a bar graph, and we've got a pictograph. And she has an error here. Well, look, we've got 5 comic books, 9 mystery books, and 3 sports books, and we simply need to find what's the error. All right, so let's look at our bar graph first. Okay, so 5 comic books. Comic is going to be 5 because look, it's right there between the 4 and the 6. That's a 5, so that's good. I've got 9 mystery. Mystery looks at 9 because it's right there between 8 and 10, so we're good there. And then 3 sports, and that's good because it's right there between 2 and 4. All right, so there's nothing wrong with our bar graph. So A is going to be wrong. C is going to be wrong. There's a problem with our pictograph. Now, when we're looking at our pictograph, we need to know that each of these represents 2 books. So this is 2, this is 2, and you see I've got half a book right there? That's 1. 2 plus 2 plus 1 equals 5, so we're good. 2, 4, 6, 8, and then I've got 9, so that's good. And then I've got 2, 4. That's the problem. I should have 3 sports books instead of 4. So my issue is going to be on the sports books. And let's see, pictograph because of mystery? No. And then pictograph because they're over sports. Should have had 1 whole and 1 half. And that's my issue right there. So we have 1 whole and 1 half instead of the 2 wholes. So my answer is going to be D. Now, let's look and see what our students answered. We had 52% of our students choose the correct answer, so slightly more than half. We had 22 choose this one, 12 and 14. Now, what's interesting is because this 22 was our biggest distractor, and it says the bar graph is wrong because the bar for sports should be 4. If you're just looking at this is 4, this is 3, so they might be thinking, oh, they don't equal each other. So we need to fix the bar graph. So they at least notice that the sports does not match each other on the 2 different graphs. The problem was that they weren't going back to the actual problem stem itself. The sports needed to be 3. So they were looking at the right one, but they weren't using the data from the actual problem. For number 13, we are looking at 3.6a, 2-dimensional and 3-dimensional shapes. So 3.6a has us dealing with, in this case, 3-dimensional shapes, and we need to find 2 correct answers that just describe this shape. Now, I would always suggest whenever we deal with these shapes, 3.6a, let's go ahead and name them. So this is a rectangular prism, and it's a rectangular prism because a prism is a 3D shape that's connected by rectangles, and it's a rectangular prism because the faces, the 2 bases, are rectangles. This is a triangular prism, so I'll put this right here because we see we've got our 2 triangles here, and they're kind of stretched out, and they're connected by the 3 rectangles. This is a cube, but a cube is a type of, and this is where sometimes our students might miss it, because if we only call it a cube, then we are going to miss it. It's a type of rectangular prism. So just like you can say a square is a type of rectangle, or a square is a type of rhombus, a cube is a type of rectangular prism. And so we're going to need that, or else we're going to miss this very first one. All of these figures are prisms. We need to know A, what is a prism, and B, that a cube is a type of, or a special kind of rectangular prism. They're not polygons because those are 2D. They do not all have at least one triangular face, only the triangular prism does. They do not have 0 vertices. Vertices are corners, and so we get corners all over the place here. We get corners here, we get corners here, we get corners here. So it's going to be the first one, and it's going to be that last one. It's going to be that rectangular face. Face is the flat side of a 3D object where edges meet. And they each have rectangular faces, including this triangular prism. It's the rectangles that connect the two triangular bases. So it's the first and fifth option here. So how did we do on this? Well, this was a 2-point problem. So for 2 points, we had 36, which is not that good. But look, we had 57% of our students get 1 point. And so together, if you combine those, it's actually not that horrible. If you take half of the 57, right, and then your 36, let's show you how we do this. We take half of 57, so that's going to be 29, 28.5, but we round up, right? That's how we get our 65. So 65%. So 65% is pretty good because you get half credit for that 1 point. That's actually going to make it our 7th easiest item on the test. Now, here's the question. Which of the items did they get correct? And which of the items did they get incorrect on the 1 point? Well, we don't know for sure. We don't get that data. But I have a feeling that we probably got this one correct. We were able to see rectangles on all of them. It takes a little bit of effort to see the rectangle on this, and we have to know that a square is a type of rectangle. So those are the two we have to look at, but we might have seen that. It's, do we know that first off, what is a prism? And do we know that a cube is a type of rectangular prism? So a lot of vocabulary on this that we're going to have to work with our students so that they can be successful. For number 14, we are looking at 3.5a. We are representing addition and subtraction problems. And so we have a library that's got 530 books at the start of the day. So look at this number line here. Where's 530? Well, if I look, I've got my 530 right here. Okay, so if I'm starting with this, start of the day, the only thing that goes here is we are moving back to the left. When we move back to the left, what is happening? Well, I'm going to move back to the left, which means I'm going to subtract something. And where's this going to end me up? That's going to end me at 280. All right, so 530 minus something is going to give me 280. I can use a fact family, and I can just do this. I can do 530 minus 280, and that is going to be 250. Okay, so something happens to subtract 250. Now, I'm at my 280, and then what happens? Well, if I start here, and I move to the right, I'm going to be adding something. And where am I ending up at? I'm ending up at 430. All right, so I have to add something to get up to 430. I'm going to use subtraction again. I'm going to use a fact family. I'm going to do 430 minus 280 to see what that missing add end is. And it's going to be 150 this time. All right, so this is going to be an add 150. So first, I subtracted 250. Second, I added 150. Let's see what happens. Well, I've got returning and borrowing. Returning means I'm adding, and then borrowing means I'm subtracting. So 150 books are borrowed. So is this the correct order? Plus 250 minus 150? No. So borrowing minus 250? Yes. And then borrowing minus 150? No. The first one is right. The second one is wrong. So returning is adding. Nope. I'm supposed to be uh, borrowing the first one. So minus 250 is borrowing, and then plus 150 is returning, and that is the correct order. So my answer here is D. Now, if you thought that was confusing, you are not too far off because this was difficult. Only 38% of our students got this correct. 30% of our students chose A. So let's look to see what's going on with A because almost as many students chose the incorrect answer of A as chose the correct answer B. Well, they reverse the meaning, right? So this has to do with returning and borrowing. So these are terms that we use in the library, and we have to correctly map. Return means to add, and borrow means to subtract. So if our students don't have any experience with library, with returning and borrowing books, they might not know that those two can map to addition and subtraction. So this is definitely a challenging contextual problem for our students, trying to figure out what this means in context, what is add, what is subtract, and this was definitely challenging. In fact, this was tied for our sixth hardest item on the test. So definitely on the harder side. Only 38% of our students got this correct. For number 15, we are looking at 3.3h. We are comparing fractions. Now, when we're dealing with comparing fractions in third grade, we don't need to draw pictures. We can compare because they either have the same numerator or the same denominator. So they have the same numerator here. So we've got Kayla, it's got 6 blocks. So that's going to be Kayla. And then Doug has 8 blocks. And they each have 3. So they give this, and we're just trying to figure out who has the greater fraction. First off, which way does the inequality symbol go? Less than or greater than, and then who has the greater quantity? Well, if I've got 6, so I will show you how this works, why it works with a picture. So let me draw, I'm going to use the connect line feature. Okay, and so I'm going to draw 2 different rectangles that are going to be equal. And then I'm going to try my best to break them up into equal portions, just to show you why this works. All right, so I'm going to make this Kayla and this one Doug. Now the eighths are easy because I'm going to take my full and I'm going to break it into half, break each half into half. I've got quarters, and I'm going to break each quarter in half. I've got eighths, so Doug's got 3/8. 6 are a little bit harder. I'm going to take my half again, but then I need to take each half and cut it into 3 equal parts, like this. So she's got 3/6. Well, you should be able to tell Kayla's got more because 3/6 is really half of it, because sixths are larger than eighths, and 6 are larger than eighths because you're taking that same whole and you're only breaking it up into 6 equal pieces, whereas Doug, we're breaking it up into 8 equal pieces. Imagine if Doug had 100, right? Imagine that same rectangle being cut up into 100 tiny little slivers. As you can tell, higher the denominator, the smaller each pieces get. So it's that inverse relationship. So Kayla's got more because 3/6 is larger than 3/8. And so our answer here is A. Now, how did we do? Well, we had 60% of our students get that, so not bad. 11, 10, and 18. And if we're getting this, probably we're just literally thinking 8 is more than 6. But when we're breaking up a whole into parts, you don't want a larger number in the denominator. You want a smaller number because that means each piece is going to be bigger. And so this was on the easier side. This was tied for our 9th easiest item on the test. For number 16, we are looking at 3.4a, solving addition and subtraction problems. And we've got this situation here, in which Casey is buying 2 different bags of beads, one that's got 250 and one that's got 400. So let's go ahead and just draw a strip diagram here, and we're going to start with, here's my 250, here's my 400. Now, they use all but 36 of the total number of beads. Well, what is our total number of beads? Let's figure this out. 250 plus 400, I'm just going to change that hundreds digit from 2 up to 6. So that's 650. And they use all of it except for 36 or but 36. And so what I want to do here is I want to draw different bar down here to show project. So there's my project. And then here's that gap that they give us, 36. Well, how are we going to figure this out? Well, let's go ahead and do 650, and let's take away that 36. So this is a two-step problem, and there's no A, B, C, or D to help guide us. We just have to enter in the answer, which is 614. And so we just have to make sure that we get that incorrect without being able to verify it with any type of possible answer choices. Now, how did we do? Well, this is a 1-point problem. You either get it or you don't. And only 39% of our students were able to get this correct. A full 61 weren't able to get this. I would expect that many students either typed in 650 or perhaps they typed in 650 plus 36 to get 686. We don't know what incorrect answers are, but this is one in which a strip diagram is going to be extremely helpful so that they can understand that they have to add the 250 and the 400, and then they're comparing that with the amount of the project, which is 36 less than that. For number 17, we are looking at 3.5e. This is real world number pairs. And we've got the number of classes that Miss Alicia teaches is equal to the number of days she teaches times 6. All right, so let's take a look at this. If we look at these tables here, we've got rules, right? We've got 6 divided by 6 is what this looks like. You could do -5, but that's not going to work down here. This is divided by 6. This is times 6, which that's what this says right here. We've got a plus 6, and then we've got a -6. All right, everything you can do with 6. Divide, multiply, add, subtract. Now, let's make sure we get the order correct here. The number of classes, so I'm going to say classes is equal to, so let's put that right there, the number of days times 6 times 6. Now, the way it's given to us is actually kind of reversed, right? So if we wanted to flip that around, we could also say days times 6 equals classes. And so we see that that matches up with exactly what's happening right here. Days times 6 equals classes. So our answer here is C. Now, this was right in the middle. This was about the 14th easiest on the test, and this is a 30-point test, a 30-item test, which means it's going to be right there in that middle. We had 51% of our students get that correct, but look at this. We had 31% of our students get A, and so that was a pretty big distractor. Let's take a look at what's happening there. Well, we've got the same order. We've got days and classes, so they didn't necessarily flip-flop them, but they just had the wrong operation. They did divide by 6. They saw that relationship, and they chose um, the wrong operation. Or they might have flipped the columns. They might have taken these numbers and thought they should be over here, because if you read it from left to right, this is times 6. If you read it from right to left, I mean. And so they might have inverted the way to read it. There's a few different ways. We need to make sure our students understand that if we've got two columns that are side by side, we're reading from left to right to find out what our rule is. For number 18, we are looking at 3.3f. We are representing equivalent fractions. And this one wants us to find an equivalent fraction that is equal to 4/6. Well, I don't see 4/6. I see 2/3. Let's just go ahead and name these fractions. I see 3/6. So the denominator is right. I see 4/8. Okay, the numerator is at least the original. And then I've got 4/4. Okay, well, I'm going to go ahead and just mark that off because I know that that's incorrect. And 3/6 can't be equal to 4/6. It's the exact same denominator, different numerator, so it can't be this. And so we'll go ahead and put this like this. 3/6 is not equal to 4/6, and then 4/4 is not equal to 4/6. Now, we're stuck with 2/3 and 4/8. Now, in third grade, when we generate equivalent fractions, we always do it with representations, either strip diagrams, number lines, objects, models. So we need to teach our students to be able to generate equivalent fractions here. So I'm going to start with this 2/3 because that's going to be easier because this 6 and this 8 are very close. And so trying to turn our 6 and 8 into the same thing is going to be difficult. But whenever we see fractions like this, we should be able to think, can I either group them together into equal groups to make us my denominator smaller, or can I cut everything in half to make my denominator larger? And look what happens if I cut it in half. If I cut it in half like this, look what I get. I get 1/6, 2/6, 3/6, 4/6. So there's my 4/6. 4/6 does equal 2/3. My answer is A. So if they give you 4/6 and they want you to find 2/3, right? If you were to do it like this, let me draw 4/6 like this. What we would say is, to find an equivalent fraction like this, look to see, do you have an even number in your denominator? Yes, so put them in groups of 2. And there you see your 2/3. So we need to teach our students ways in which to generate equivalent fractions with these representations. Now, this one was, like I said, just about equivalent fractions. We had the pictures there, so that makes it about middle of the road. 50% of our students got this correct. This was tied for our 14th most difficult, so right in the middle of the road. Now, our biggest distractor was right here, this 24. Now, we know that 3/6 is not equal to 4/6, but they see the word equal. Students might not be sure what to do, and they see at least the denominator is the same. So they might have picked that simply because the denominator was the same, knowing that it wasn't equal, but they didn't know what else to do. So we need to give them practice with these representations and either cutting them in half to generate fractions with larger denominators or grouping them into groups of 2 if it's got an even number in the denominator to make fractions with smaller denominators. For number 19, we are looking at 3.3e. Now we are partitioning objects here. And so we've got this school, 4 students to paint a wall. Here's the wall. So the wall is in eighths, okay? And what fraction will each student paint? Well, there's 4 students. Now, if I'm not necessarily paying attention, I might think there's 4 students, there's 8 sections, and you see what one of our answer choices is 4/8, which is actually our biggest distractor. It's not as simple as that. What we need to do is we need to break this up into 4 groups because there's 4 students. And when we can see that we've got 8 sections, this is one of these to where we look. Is the denominator even? Yes. Can we put them in groups of 2? Let's try that and see what happens. 1, 2, 3, 4. There we go. And so each of these students is going to paint one of these columns, which ends up being 2/8, or we could label these as 1/4 if we want to. So this is very similar to the previous problem. We need to be able to give them a model and have them generate equivalent fractions there. In this case, we're not necessarily generating equivalent fraction, it's just the straight up 2/8. But if this were another standard, we could have asked for that as 1/4. And so how did we do here? Well, we had 50% of our students get this correct, which is about middle of the road, just like last one. It's the 14th hardest, or at least tied for our 14th hardest. But our biggest distractor was, as you can guess, this 32. And we also had students choose 1/8, which is just 1 unit here. And then 32, obviously, they just took the 4, they see it's an 8, so they slap those together. But 4 kids can't each do 4 eighths because that means 2 kids would fill up the entire wall. 4 eighths and 4 eighths make 8 eighths, and you would have 2 kids not doing anything. So this is one in which we have to put it in context. We really have to keep these 4 students in mind. For number 20, we are looking at 3.6c, the area of a rectangle here. And we just need to find the area here. And as always, we are given grid lines to kind of help us. Now, if we want to, we can try to draw these grid lines across. And we can just kind of bring it down. It's not going to be perfectly even, but this rectangle is kind of sitting on top of this grid line, so we can kind of figure out what it's going to be. And let's figure out what it is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm just going to do sets of 9, 18, 27, 36. It's 4 down. So 4 times 9 equals 36 square centimeters. So our answer here is C. How did we do? Well, middle of the road. We had 50% of our students get this correct. 18. Now, the incorrect answers were kind of all over the place. Let's talk about them here. And it's ended up being, just like the last few, tied for our 14th most difficult, so right in the middle of the road. A student chose 50 square centimeters. They counted the grid lines. So if you count the grid lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 5. So that's interesting that they would choose that. So they weren't quite sure what to do, but they at least counted those grid lines. 26 square meters, well, that's the perimeter, so it wouldn't be in square meters. It would be in centimeters, but this is 4 plus 4 plus 9 plus 9. And then our 30 is actually the unshaded. So if you count all of this right around here, that's actually 30. So they did a lot of counting, and they weren't necessarily picking up on this word shaded. So extra exposure to when it has grid lines. Sometimes we'll see a problem like this, to where you'll get an area problem, and they'll just get the first row and the first column started, and they'll want students to figure out what the total area is. These are the two different ways they'll ask them for area for 3.6c. They need to be familiar with both. For number 21, we are looking at 3.4k multiplication and division problems. As you can tell, this is an equation here, equation editor, so we're just typing in the answer. No A, B, C, or D to choose from, which always makes it a little bit more difficult for students. Frank puts 90 pictures in a book. He put 6 pictures on each page. So we've got equal groups, but we have our total. So we've got a total of 90. We need to be able to recognize that. Do we have a total? Yes, there's our total. And then 6 pictures on each page. How many pages? Well, I'm going to put like this. I've got groups of 6. How many groups of 6 can I make? So really what this is 90 divided by 6. Well, we don't really get into long division in 3rd grade. It wouldn't hurt for them to know, because long division can help you with this. We can also do it like this. We can use an area model. So I'm going to break my 90 up, and this is how students can use this if they're not familiar with long division. I'm going to take my 6 and my 90, and I'm going to figure out, right, what my other factor is in here. Now, my 90, let's put that in there. That's where it's supposed to go. I'm supposed to figure out what my other factor is on the outside. I'm going to take my 90 and I'm going to split it up into manageable chunks. And so what I'm going to do is, let me overlay this with blue. I'm going to put 60 up here. And I'm going to put 30 right there. Now that's something I can do. 6 times what gets me 60? Well, that's 10. 6 times what gets me 30? That's 5. So this side here is 10 and 5 altogether, which means it's going to be 15. That's one way to solve it. We can verify 15 times 6. There's your 90. So our answer here is 15. And like I said, this has no A, B, C, or D to choose from, which means it is going to be a little bit difficult for students. And in fact, we only had 35% of our students get it. This is a 1-point problem. And this was the 5th hardest on the entire test. So this is a conceptual problem, and we need to teach students. We don't necessarily need to worry about the algorithm for long division yet. They really get into that in 4th grade. If we could have drawn some type of thing here and recognized how to break it up, we could have solved it using the area model that we're already familiar with. Typically, when we do area models, though, we will do it like this, and then we'll put it like this on the outside, right? What we need to do is we need to think about we can use that for division, and we can just put that 90 or the 60 and the 30 on the inside and then look for this missing factor. For number 22, we are looking at credit. 3.9D. This is personal financial literacy, which means this is going to be mainly understanding and vocabulary. So we need to find an example of credit. Well, if we don't know what credit means, then we're just guessing. And the answer selections definitely show that most of our students were just guessing. So what does credit mean? Well, credit means when you use someone else's money to pay for something. So that's just a basic street level definition that we need our students to be able to understand. If I'm using credit like a credit card, I'm not paying myself. Somebody else is paying for it, and I'm going to pay them back. So if we pay sales tax at a restaurant, that's not necessarily credit, that's tax. If we save part of our income at a bank, well, we're not paying anything, we're saving, so that's a no. We're using cash, nope, it's at least paying for something, but we're using, this is our money, so that's no. And they're getting a loan to pay for a car. So you see we have got pay in 3 of these. And this is a loan, and then we're inferring we're getting a loan from the bank, the credit union, something. And so that is our answer, B. We're getting a loan for somebody else to pay, but that comes from knowing what credit is. Only 29% of our students got this correct. Actually, more students chose B, saving part of our income, and I don't think they necessarily got confused. They probably just were not sure what credit was. And if you think about it, this is the only one that's different. So they were using their thinking skills. This is the only option that's not paying. And so that's actually a decent strategy because look, we've got paying, paying, paying. And so the one that's correct should be the one that's different. But the people writing this test know that. And so they're going to take that option out. And that was our most chosen incorrect answer. So we can't just use strategies. We have to teach personal financial literacy. They're all supporting standards. We don't devote a lot of time to it, but we need to use a lot of real world examples because some of our students might have missed meets or masters by 1 point, and it might have been this one. This was actually very difficult. This was the 3rd hardest item on the test. And so definitely worth some of our time. For number 23, we are looking at 3.5C, multiplication as comparison. Now, that's a standard that we sometimes don't spend enough time on because we always think multiplication, huge emphasis in 3rd grade, as equal groups of, but sometimes it's also as comparison. So we've got a restaurant that sells 38 pizzas on Wednesday. The expression 38 times 2 can be used to find the number, and then look at this. 38 times 2 times 2 times 38 times, and then it's either Wednesday on, this is a lot of words. And it's because the standard actually uses the verb describe. We're not calculating, we're describing. So we have to be able to use words. And so our students need to have access to this. So what is this 38 times 2? Okay, what can we tie the 38 to? The restaurant sells 38 pizzas on Wednesday. So this is Wednesday. And then the expression 38 times 2 can be used to find out. So that's going to be equal the number of pizzas on Saturday. So I'm just going to write like this. If our students can at least get this 38 times 2 equals Saturday, then that's going to help us. So there are 38 times as many? Well, no, we're not 38 times as many. We're multiplying it 38 by 2. 38 is simply the number of pizzas sold on Wednesday. So we can get rid of this. We need to be able to read it in the correct direction. So there are 2 times as many sold on Wednesday as Saturday. Now, if we take our Wednesday, we multiply by 2, that's what gets us to Saturday. So there are 2 times as many pizzas sold on Saturday as Wednesday. So that is our correct answer of C. That's a lot of reasoning, and students are not going to have access to a problem like this unless they practice this, and not just with words written on a piece of paper, but verbal descriptions, talking out loud, group activities, partner work. They need to be able to have some practice taking these multiplicative comparisons and putting them into real world context. Only 40% of our students got this correct. And so 29% got this. Now, between those two, you have 69%. They at least knew that it was 2 times. But we still had 20 with this and 11 with this. So this was a very difficult problem. This was the 10th hardest item on the test. There's not really any calculation. It is a describe verb. And so, much like the personal financial literacy, it's a lot of description and understanding or explaining. And so that means the answer is going to be in the form of sentences, not necessarily calculations. For number 24, Evie is finding the sum of 7 hundreds, 110, 15 ones. This is 3.2a. We are composing and decomposing numbers. And we need to find out what this could be. 70 hundreds. That's interesting. All right, so if I take my hundreds, I'm going to take my place value chart. Okay, so I've got 70 hundreds. Well, I can't put 70 right there. This is my hundreds, my tens, my ones. You can only put one digit in each. So what we're taught to do is you just put the final digit here, and then everything spills over to the left. All right, so the first thing we need to figure out is 70 hundreds equals 1,000 would be 10 hundreds, so 7,000s would be 70. Because look, 10 hundreds, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So I've got 7 sets of those 10, which means I've got 7,000. All right, let's do our 110. That's easy. And then I've got my 15 ones. Okay, so I could put my 15 right there, but same thing. It's not going to be this, right? We're not putting 2 digits in one. So same thing. We're going to put our last digit there, and then the other spills over. But I've already got a 10. So I need to add these together to make 2. So I need to rewrite my 70 hundreds as 7,000. I need to write my 15 ones as 110, 5 ones. And I need to add that 110 with this 110 to give me that 210. So I've got my answer here of B. Now, this was challenging here. As you can imagine, only 39% of our students got this correct. 22 chose A, 27 chose C, and 12% chose D. Now, if you look at A and C, those are pretty big numbers. Most likely they wanted to see the 70. So they both have that 70 right there. There is a 70 in the correct answer of B, but it's kind of interspersed with that comma, so it doesn't really look like a 70. And this one, what they did is they just didn't combine the 10 from the 15 ones and then the other 10. They just stacked them up next to each other. And so this was pretty challenging for our students. In fact, this was tied for our 8th most difficult item on the test. And so when we are working with composing and decomposing numbers, we need to think about it using this type of structure here, right? We're going to need to rename more than 10 sets of a place value so they can rename it. But they also need to rename it in which it bleeds over into an existing one, right? So you might get 15 tens and then 300s. So they'd have to rename the 15 tens into 105 tens and then add that 100 to the existing 300s. Things like that, where they have to do a little bit of addition. That's going to give them the rigor that they need to succeed. For number 25, we are looking at 3.48 equal shares. And so this is an interesting problem. This is a hot spot, and we just have 24 marbles. Here they are, and 3 groups of equal size. Now, it would be really easy if they were in 3 rows, but they're not. They're in 4 rows. And so most students that get it wrong are just going to, maybe just select one row there. But I just need to take my 24. I need to put it into 3 groups. I just need to select 8 because it says I need to select the number of marbles that are in one group, one equal group, 8, 16, 24. That's it. We don't need to overthink this. And so I need to select any 8. Any 8 is going to work. So 1, 2, 3, 4, 5, 6, 7, 8. Right? If we wanted to do it vertically like that, we could see that we've got equal groups like this. Not with rows, but we can see them with columns. Right? 8, 16, 24. So this was a 1-point problem. This is a hotspot. You either selected 8 or you didn't. And we got 48% of our students, they were able to get that. So not too horrible, but this was kind of right in the middle of the road. Difficulty for our students. Number 26, we are looking at time intervals. This is 3.7c. And we've got this time on the clock. So Emma reads for 1 hour, 20 minutes, and she finishes at 7:13 as shown on the clock. All right, so this is 7:13. So what time did she start? All right, so this is her ending time. So I'm going to draw a number line here. So here's my 7:13. And then what we need to do is we need to go back to my starting time, 1 hour, 20 minutes. Now, we can't just line it up and subtract vertically. That doesn't work anytime you go over an hour because we don't have a base 10 system in our analog clocks. When we use just time like that, it's going to be a base 60 because there's 60 minutes an hour, not 10 minutes an hour. So the normal rules don't apply. So it's easier to use this time interval, this number line here. So what I want to do is I want to take 20 away from this, but I'm going to do it in chunks. I'm going to do it up here. I'm going to take away 13 minutes. The reason I'm doing 13 minutes is because I know that 7:13 is 13 minutes past the hour. So this came from my 20. So I'm going to break this up into a 13 and a 7. So now I need to just take another 7 minutes away. And so I need to think what's 7 minutes before 7 o'clock. That's going to be the difficult one, but it's going to be an hour 6. And then it's from 60. So 60 minus 7 is going to be 53. So this is the big part right here. It's trying to figure out, making sure we understand this is a minus 20. I did it in 2 chunks because I wanted to get to the hour and then past the hour. And then after that, it's pretty easy because I just need that 1 hour left. And so I'm just going to make this big jump right here. From 6:53, it's going to be 5:53. So there's my answer of B. How did we do? Well, only 41% of our students got this. The rest were kind of spread out a little bit. And so if we got this 27%, they only subtracted the 1 hour. They did the 7:13 minus the 1 hour. They just missed the 20 minutes. And then if you got this 18%, right, they only subtracted the 20 minutes, or what they might have done is they didn't necessarily regroup. They might have tried it vertically. They might have done like this, and they might have just brought this down and done like, 53 like this, and then subtracted the 1 hour to get the 6:53. Like they didn't change the time when they took that 20 minutes away. They didn't change this hour. Either way, this was a difficult one. This was tied for our 11th most difficult. And so when we're dealing with time intervals, which is obviously a standard, this is 3.7c. This is probably the easiest way to think about it is by using these number lines here and just thinking of jumps and decomposing our numbers that we're either adding or subtracting into numbers that get us to the hour or from the hour. Number 27, we are looking at 3.2b, place value relationships. This is a 2-point problem. We've got one point for each of these blanks that we're going to fill in here. And so let's take a look. We've got our 858,386, and we're simply comparing the 8. Okay, so I've got the 8. I've got 3 8s. Okay, so let's go ahead and put this in a place value chart. So I've got 8, 5, 8, 3, 8, 6. This is my ones, tens, hundreds, my comma, 1,000, 10,000, and then 100,000. All right, the value of the 8 in the 100,000s place, let's deal with this one first, is blank times greater than the value of the 8 in the thousands place. I'm looking at these two right here. Well, in our base 10 number system, we need to know that each place value is 10 times greater than the place to the right. So when we're going from this 8 over here, if we want to go from the 1,000 to the 10,000, how many thousands does it take to get to 10,000? Well, this is going to be a times 10. Will get us right here. 10 1,000s gets us 10,000. How many 10,000s does it take to eat 100,000? Well, that's another 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, if I wanted to go straight from my thousands to my 100,000s, well, how many 1,000s does it take to get to 100,000? Well, I can count by ones, and I'd be counting for a long time because it's times 100. Because it's really 10 times 10. Every time you move to the left, you multiply by another 10. So 10 times 10 would be 100. So the 8 in the 100,000s place is 100 times greater than the 8 in the thousands place, because 100 thousands make a 100,000. Now, let's look at this next one, the 8 in the 100,000s place. Okay, so I'll do this in green, so I keep it separate. Is blank times greater than the value of the 8 in the tens place? Okay, that's a lot of tens, but let's do it. So it takes 10 tens to make 100. It makes 10 100s to make 1,000. Makes obviously 10 thousands to make 10,000, and it makes 10 10,000s to make 100,000. How many tens do I've got? 1, 2, 3, 4. So 10 times 10 times 10 times 10. All right, let's do this in chunks. 10 times 10 is 100. If I multiply that by 10, 10 hundreds makes 1,000. And you notice what I'm doing is I'm just adding a 0. Right? When we multiply with these, we can just look at the zeros. There's 3 zeros here, there's 2 zeros here. So if I take that 1,000, multiply that by 10, so here's my first two tens, my third 10, and my fourth 10. I've got 1,000 times 10. Well, that's going to be 10,000 because I've got 4 zeros right there. So 10,000 times greater. And if you think this was a struggle for our students, you are correct. This was our second hardest item. And if you're looking at just how many students got both points, then it's going to be the most hardest, but they do get partial credit here. So only 11% of our students got both of those. Only 29% got one of those, and I'm thinking it's probably this one right here. A full 60% of our students walked away with 0 points. They just did not understand how to do this. And so we really need to, when we put those together, we get 26% correct if we take half of that 29. We really need to spend time on the base 10 number system. They're going to need it again next year in fourth grade when they add decimals. It's going to be the same idea. But help them go back and forth, left and right, by either multiplying by 10 or dividing by 10 to get bigger or smaller. That's going to be important for our students, and they just need practice with this. Because once again, this isn't much of a calculation. It's more of just describing. Because that's the verb. If you read the TEKS, it's going to say describe, so we need to describe rather than calculate. 28, we are looking at 3.8b. We are solving data problems. And we've got our owner of a hotel as a scale. Each dot represents one guest's rating, so each dot is a guest, okay? How many guests rated the hotel fewer than 3 stars? Fewer than 3, which means we're not including 3, which means we're just looking at that. So if they said 3 or fewer stars, then we could have included 3. But if it just says how many guests rated the hotel fewer than 3 stars, well, the only numbers less than 3 are 1 and 2. 3 is not less than 3. Obviously, 4 and 5 are larger than 3. So I've got 1, 2, 3, 4. That's it. I've got 4 of our students, or 4 of our guests that rated it as less than 3 stars. So only 33% of our students got this correct. Look at this. 40% of our students chose A. Now you might be thinking, how in the world did they get 2? Well, how many choices are there less than 3? There's 2 choices less than 3. There's 1 and 2. But they weren't looking at the question, how many guests, not how many ratings, how many guests. And they needed to obviously go to our key to realize that each of these circles represented a person. So more students chose that, which means they were looking in the right section, because neither one of those obviously is 2. They were looking in the right section. They just didn't apply the key here. So remember, most of what we do with data is 3.8a, which we're representing data, but when we deal with 3.8b, we are solving data. So we also need them to be able to solve, not just represent. If all we're doing is representing, we're not setting our students up for success. This was the fourth hardest item on the test. 29 is looking at estimating addition problems. This is 3.4b. We do have a drag and drop 2 points. And you get 2 points if you get 3 correct. Let's go ahead and put the scale here. 2 points. If you get 2 out of the 3 correct, you only get 1 point. And then you get 0 points if you get 0 or even 1 correct. So 1 correct doesn't get you anything. You need at least 2 correct to get half credit on this. So we got 67 green marbles, 54 green marbles. We're rounding each number to the nearest 10. All right, so let's think about this. If we take our 67, it's going to be within our benchmarks of 60 and 70. Our halfway point is going to be 65, so 67 is going to be right about there, which means it's going to round up to 70. Let's do the same thing with 54. So 54 is going to be between 50 and 60. And our halfway point is 55. That's right below that. So 54 is right there, and so which means it's going to round down to 50, closer to 50 than it is to 60. And then I just need to add these two, 70 and 50, that's going to get me 120. So if we get all 3 of those, we get 2 points. How did we do with that? Well, we had 53% of our students get all three correct. Not bad. We had 11% of our students get one correct, and then we had 36% of our students get zero or one correct. So that's actually quite a bit that didn't get any points. But this still lands us on the easier side. This was the 11th easiest, because remember, we do get that partial credit. So we get to add half of that 11, round up, that's going to get us 59%. So close to that 60 threshold that we like. Our final question is number 30, 3.2D. We are comparing and ordering numbers, and we need to find a number that can go in this box. All right, so we're comparing three numbers, and let's just look. So our larger number is going to be this right here. So it's reading in order from left to right, from smallest to largest. So I'm just going to kind of write like this. I want to put my largest up on top. 779, 46, 523. Let's get some lines, and I just want to kind of stack my possible answer choices in between here, see what makes sense. All right, so I'm going from greatest to least. You could do from least to greatest, your choice. That's just how I want to visualize this. So my first one is going to be 47. Well, I can already tell you that's not going to work. Look, that 7 in the thousands place is larger than my greatest number, so we're done. All right, so 46, we're doing good so far. 5, 1, 8. We're good up to here, but then this is where I have problems. This is actually less and would go down here, so that's not going to work. 46, so far so good. 5, yes. 7, 5. All right, so this 5 and that 7 is going to put these two up above here, but below here. All right, so that looks good. Let's see what's wrong with this one. 45, wrong. That 45 is going to be below there. So it is going to be this third one, C. And this was a fairly easy one to end on. We had 60% of our students get this correct. We had 24 choose A, so that was a pretty big distractor. Let's look at that. And so they only considered this first one, this 47, right? If you're looking at right here, and you just say 46, 523, if you're not drawing my thing, if you just want to look at it like this, it does work. 47, 623. So this part works, but they didn't necessarily bring this into it, because what doesn't work is when you bring in that second boundary. That doesn't work. So they might have only considered the first one. But overall, this was pretty easy. This is actually tied for our 9th easiest item on the test.